All right, well, why don't we move up the complexity just a little bit in this adding and subtracting rational expressions, where we're dealing now with complex fractions or fractions over fractions, if you will. And so one of the methods that we can use is we can look at handling the numerators and the denominators separately first, then combine them back together, and then simplify. So here we've got 1 over y over x, and that's over or divided by 1 over y plus 1 over x. So let's first think about the numerator. So we got 1 minus y over x. And so we're subtracting from 1 y over x, so we need to get this to a common denominator. Well, I got a denominator of x here, and I've got a denominator of 1 right here. So I can multiply this 1 by x over x, which is just 1 again, times 1 minus y over x. And then that's going to give me x over x minus y over x. And that's going to be what my numerator is. Now I'm going to go over here on the far side, right side, and let's look at the denominator. Well, we've got 1 over y plus 1 over x. Well, to get to a common denominator, I'm going to need a denominator of xy. So let's divide the 1 over y, multiply the 1 over y by x over x times 1 over y. And we're going to multiply, I keep wanting to say divide, but multiply 1 over x times y over y. And so this is going to give me x over xy plus y over xy. Now, let's combine that back into a complex fraction. So my numerator then is going to be x over x minus y over x. And all of that's being divided by x over xy plus y over xy. Now I can simplify this further by just writing it like x minus y over x plus y over xy. Now anytime we're doing division, a fraction over a fraction, this is the same as x minus y over x times xy over x plus y, the reciprocal. Now, in this form, I can see that my x here and my x here are going to cancel. So then I've got x minus y times y over x plus y. And when I do, I'm gonna put it below, but you see where I put the equal sign. So I've got x minus y times y. Well, that's going to be xy minus y squared over x plus y. And that, my friends and neighbors and countrymen, is the answer. So we dealt with the numerator first, the denominator, took them separately, combined them back together, and then we used the inverse property of division to multiply the two fractions together, multiplying the top fraction by the reciprocal of the bottom fraction to solve. Let's do one more. All right, so along the same lines, here we've got c over d minus d over c, and all of that is over or divided by d over c plus 2. And so again, we're going to look at the numerators and the denominators separately. So we've got c over d minus d over c. And again, I've got to get these to a common denominator. Well, let's see, I got a D and a C, so we're going to multiply C over D by C over C. That's going to give us the denominator of CD minus, and here we got D over C, so we're going to multiply this by D over D. Again, we're trying to get this numerator, this complex fraction, to where the numerator has a common denominator. Well, C times C is C squared, and we got CD. C times D is CD minus, and D times D is D squared over CD. Let's go ahead and combine this, simplify this to C squared minus D squared over CD. Now let's move to the other side here and let's deal with our denominator, which is D over C plus 2. Well, I got to get this into a common denominator of C, so I'm going to go D over C plus 2 times C over C, which is just 1, so I'm not really changing the value. Looks like it because I've got variables involved here, but I'm not. So I've got D over C plus 2C over C, and we can simplify that to 2 plus 2C over C squared. I'm sorry, just C, not C squared. Adding those. All right, so now let's rewrite the whole thing. Now we can say, move our numerator up to here. So I got C squared minus D squared over CD, and all of that is over D plus 2C over C. And again, just like what we did before, we're going to multiply this expression by this expression, or divide, and we divide by multiplying by the reciprocal. So we got C squared minus D squared, running a little bit short of room, CD times C over D plus 2C. Okay, well, I can do a little cross multiplication here, and the C is going to cancel. And so my numerator then is just going to simply be C squared minus D squared. But in my denominator, I can distribute the D to the D plus 2C, which is going to give me D squared plus 2CD. And that, again, friends, Romans, countrymen, is our answer. Ah, yes. Isn't this fun?